Hi, this is Dr. J. Vikas Paul. In this session, we'll discuss about shear stress for unequal flanges of I section. So let us see a problem. A cast iron subjected to bending has cross section of I shape which has unequal flanges as shown in the figure. If the section is subjected to shear force of 120 kN, draw shear stress distribution diagram over the depth of the section. So we need to draw the shear stress distribution diagram. This we need to draw. This is given. So I section of unequal flanges is given. That means, so this is unequal flange. These are unequal flanges having different dimensions. So dimensions are shown here: 240, 40, 240, 40, and it is 120 and 40. Yes. Now we need to draw now what is our general formula for shear stress? Fa tau equal to Fa y bar by Ib. So F is given as 120 kilonewton shear force, 120 into 10 cube newtons. So H plus. So for this type of I section unequal of flanges, we don't know where the exact centroid is, because the neutral axis will be on the centroid. So first we need to find the centroid x bar y bar. So if we take this as reference axis, so x bar will be half of this, so 240 by 2. On this x bar will be. Now on this, where is y bar now? We need to find that y bar. So what is the formula for centroid? X bar is 240 by 2, 120. Y bar formula is this one. So if we consider it as 1, 2 and 3, so a1 y1 plus a2 y2 plus a3 y3. So a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So what is a1? 240 into 40. What is y1? Distance from base to this neutral axis. This is y1. So 40 by 2 plus 240 plus 40 plus 240 by 2 plus 40 by 2. Yes. Next, A2, this area of this rectangle, this portion 2. So 240 into 40 into, so what is this distance? 40 plus 240 divided by 2. So from base, the neutral axis distance of the neutral axis of this portion, and from base the distance, right, plus 120 into 40, 120 into 40 third portion area into y3 means from base the neutral axis of third portion, this distance 40 by 2. So a1 a2 a3. So y bar we will get as 188 mm from bottom. From top it is 132 mm. So from bottom it is 188, from top 132 mm. Next, now I. So I equal to ixx1 plus ixx2 plus ixx3. The formula is this one: I1 plus a1 h1 square, I2 plus a2 square plus I23 plus a3 h3 square. Now, so first I1 plus a1 h1 square. I is means for first section, ixx1 we are finding. So BD cube, as it is rectangle, BD cube by 12 plus its area h1 square. Its area is 240 into 40. 240 into 40. What is this? H1. H1 is nothing but distance of overall neutral axis, distance between overall neutral axis and neutral axis of this first portion, means this distance. Sorry, this is y bar, no? So this is h1, overall neutral axis minus distance between overall neutral axis and the first section neutral axis. This is h1. Next, so we will get it as this one. Next, so ixx2 equal to I2 plus a2 h2 square. Here I2 is bd cube by 12 of this portion. B is 40 and 240 is d. So 240 to 240 cube by 12 plus area a2. This area 240 into 40 and h2. What is h2? Distance between overall neutral axis. This is, and neutral axis of this portion. This is h2. So it is 28. Next. So how 28? 188 minus 120 plus 40, 160. So 188 minus 160, 28. Next, 28 square. Then ixx3 means for this portion. I3 plus a3 h3 square. I3 is 120 into 40 cube by 12 plus a3 120 into 40, and h3. What is h3? Distance between overall neutral axis and this portion, neutral axis of this portion. This is h3. So h3, if we calculate, we will get it as 168. So 188 minus 40 by 2. So 168 will get. So if we calculate, we will get it as, I will get it as the 311.41 into 10 power 6. So tau top flange fa1 y1 bar by ib1. So for top flange, we need to find the shear stress now. So f is given as 120 to 10 cube. Area, we know the area, and y1. So what is y1? Distance between neutral axis and neutral axis of this flange. That is y1, 112. Divided by I into I we have found. B1 is this one, 240. 240. So we'll get this one. So this value is 1.726 Newton per mm square. Next, tau web. Tau web means at this portion, exactly at this portion. So the same formula, but at B we need to change it as 40. This thickness 40 we have to write. Or we can do like this. Tau is inversely proportional to 1 by B. Tau 1 by tau 2 equal to B2 by B1. In this way also we can find tau web. So here we have got it as 10.358. This value. Then tau max at neutral axis. F into, this is the formula. So that means for this tau max we need to find, we need to take these two portions, 1 and 2. A1 y1 bar plus A2 y2 bar. So if we know A1 means area of this portion, y1 means overall neutral axis distance, and distance between overall neutral axis and this portion 112 plus 40. So this portion 40 into 92, this is 92 into 40 into 40. What is 40? The distance between this portion and this portion. This overall neutral axis and this neutral axis. So if we calculate, we'll get 12. So this value is 12. Now tau bottom flange, if we calculate, this is the formula. If A3 y3 bar by I B3. If we know A3, also we know the area for this section, third. This is 3 now, this flange, yes, into y3. Y3 is 168. Y3 is the distance between overall neutral axis and neutral axis of this third portion, y3, 168. So I we know B3 is 120. This is 120. 120. B3 is 120. So we'll get it as 2.5 Newton per mm square. So this value is 2.5 Newton per mm square. Now we need to find this value. So tau bottom web equal to fa3y3 by I b2. So this everything is same, but this value is 40. Means this thickness we need to take 40. So we'll get 7.768 Newton per mm square. So this is a complete shear stress variation from top to bottom of this unequal flange I section. Thank you.